Hello everyone. In this lesson, you are going to look at the double integral over general regions. In our previous video, we looked at how to find the double integral of a rectangular region. So with double integral over a general region, we have two cases. We have the first case and the second case, which is, with the first case, we have a region where the limit of the y is a function of x. And for the second case, the limit of x is a function of y. So we are going to look at how to handle both cases. So with the first case, we are going to look at the first example, which is example 1, where we have the double integral of e power x over y with limits y from 1 to 2 and x from y to y cubed. So with our first case, we can see that the first case qualifies for case 1. So we are going to find the double integral of e power x over y. So to find the double integral of this, we have to first integrate with respect to x first, because x has a function of y. When you integrate with respect to y first and end with the integral of x, you realize that you have your final answer to be a function of y. But when you start with that of x, which has a function of y, and end with that of y, you end up getting a constant. So that's why we always start with the limit which has a function of the other variable. So here x is a function of y. So we are starting with respect to x first. So we have y to y cubed with respect to x. So we have this 1 to 2. So now, to integrate this, you have to first anytime you're integrating e, you first differentiate the power first. So when you differentiate the power with respect to x, you get 1 over y. Now, since this is integration, you have to find the inverse of 1 over y, because integration is the opposite of differentiation. So the inverse of 1 over y is y. So you then multiply y by e x over y. So you have y e x over y. And the limit is from y to y cubed. So we have 1 to dy. So you end up getting, so you do upper limit minus lower limit. So you end up getting ye. So since we integrated with respect to x, wherever you see x, you put in y cubed for the upper limit and you put in y for the lower limit. So we have y cubed over y minus ye y over y. So here and I'm getting y squared. So you have integral of ye y squared minus y e with respect to the y. So now we are done with the first integral. So we are going to find our next integral. So then, to integrate this, here we have two functions of y. So we apply integrating by parts. So this becomes our x. So our x becomes, or let's say our u becomes the y squared, and our dv becomes the e power y squared. So when we consider u to be y squared, we find du dy is 2y. So you have dy to be equal to du over 2y. So here we have eu, and dy is du over 2y. So you factorize out, so you have 2y EU du. So now we know that when you integrate EU, you get EU because when you differentiate you get 1, and 1 times the whole of this is also 1, so you end up getting 1 over 2 y e u from 1 to 2. Now our u is what? Y square. So you have y square. So now we bring this here, so we end up getting 2 half 2y y square Man, then find the integral of this. Integral of this, we will get y square over 2e. So we are done with the integral, and it's from 1 to 2. So we put in 2 first and put in 1 later. So we have, wherever you see y put in 2, you have 1 over 4e 4 minus okay, put in, so e4 over, sorry, here it's supposed to be 4. They have e minus, and you put in 1, you have 1 over 2e minus 1 over 2e. So with this you can see that, okay, with this you can see that this will give us 0. So we end up getting 1 over 4e minus 2e. So we can factorize e out to get 1 over 4 minus 2e. Then go on to simplify this. You can go on to simplify this to get. So now, to save yourself from all this stress, when you get to this particular point, you can use your calculator to just do this, so that you can save yourself from all these stresses. So you can use a calculator to just punch this one straight, since it's just one variable, and that will save you a whole lot of stress.